Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about the instrument wave analyzer. In this video we are going to study that what is wave analyzer, what is its block diagram, its working and its applications. So let us start with our topic. In the electrical and electronics engineering, there are many applications in which the analysis of signals become very necessary. So for the analysis of signals, there are various instruments available like wave analyzer, distortion analyzer, spectrum analyzer, radio frequency analyzers and the modulation analyzers. So here we are studying about the wave analyzer. So let us first get some introduction about these analyzing instrument. Now, as I have said that all these instruments, they are used for the analysis of the signal. So what does that these instruments they are going to measure? These instruments, these signal analysis instruments, they basically measure the basic frequency properties of a signal. So if we are saying that we are doing the analysis of a signal, it means that we are measuring the basic frequency properties of a signal. So all these signal analysis instruments, they are measuring the basic frequency properties. But the difference between these instruments is that they are using different techniques for this measurement. Like for example, we are having the spectrum analyzer. So the spectrum analyzer, it is going to sweep the entire frequency band, means over the entire frequency band it is being used, and it is going to display a plot which is of the amplitude versus the frequency. So we are measuring the frequency in relation with the amplitude. So we are getting the plot of the amplitude versus frequency over the entire frequency band in the spectrum analyzer. Now this spectrum analyzer, it has an operating range of 0.02 Hz to 250 GHz. So the operating frequency range of these instruments is also different. So if we are using different frequency range, so for that we will use different instrument for the analysis. Now if we talk about the wave analyzer. So wave analyzer is a type of voltmeter . So wave analyzer, it is basically a type of voltmeter which can be accurately tuned to measure the amplitude of a single frequency. Now in the spectrum analyzer, over the entire spectrum of frequency, we are plotting the amplitude and the frequency graph. Okay. Now here in the wave analyzer, over a particular frequency only we are measuring the amplitude. Okay, so that is different from the spectrum analyzer. So both are measuring the frequency, but the frequency range is different. In the spectrum analyzer it is over the entire frequency range, and in the wave analyzer it is for a particular or for a single frequency. Now the operating frequency range of this wave analyzer is 10 Hz to 40 megahertz. So you can see that the frequency range of both these analyzers is also different. Next type of signal analysis instrument is the distortion analyzer. Now the distortion analyzer, they operate over a frequency range of 5 Hz to 1 megahertz. And they are going to measure the energy present in the signal over a specified frequency band. Okay, we are going to give a particular frequency band, and the energy present in the signal over that frequency band will be measured by the distortion analyzer. So distortion analyzer, it measure okay. So they are going to be tuned out of the fundamental signal, and then they give the indication of the harmonics present in the signal. So distortion means in the signal if the harmonics are present, it means distortion is present. So it is measuring the energy present in a signal out of a specified frequency band. So it is going to give us an indication of the harmonics present in the signal. Now next type of signal analysis instrument is the audio analyzer. Audio analyzer is just like the distortion analyzer, but it is going to measure the additional features also, like it can measure the noise present in the signal, because we see that in the distortion analyzer we are getting an indication about the harmonics present. Now if some noise and disturbances and spurious signals are also present in the signal, then that can also be measured with the help of the audio analyzer. Now next type of analysis instrument is the modulation analyzers. Now in modulation analyzers, they are tuned to the required signal, and then they are going to recover the whole amplitude modulated, frequency modulated and phase modulated envelope for the display and the analysis of the signal. So you can see that in the modulation analyzer, the signal and its modulated forms, amplitude modulated form, frequency modulated form and phase modulated form are also used for the analysis of the signal. So you can see that we are having the different signal analyzers which are analyzing the signal, means they are measuring the frequency properties, but they are using different techniques for that measurement. Distortion analyzer, it is measuring the harmonics present in the signal. Wave analyzer, it is at a particular frequency, it is measuring the amplitude. Spectrum analyzer, over the entire frequency band, it is measuring the amplitude of the signal. Audio analyzer, it is measuring the noise also present in the signal. And modulation analyzer, it is giving us the display of the modulated signals also. Okay, so these are the different signal analyzers which are used for the analysis of signal in the electrical and electronics field. Now Here in this video we are going to study about the basic wave analyzer, that what is a wave analyzer and how the basic wave analyzer works. Now we know that if we are getting any periodic waveform, if we see any periodic waveform, then that periodic waveform is represented as a sum of its fundamental and the harmonic components. So any periodic waveform, it is represented as a sum of the fundamental and the harmonic components. Now if we talk about the fundamental component, then it is the DC component, and if we say the harmonic components, then it is the sinusoidal components. So whenever we are doing the analysis of a signal, the signal is a complete combination of the fundamental component also and harmonic component also. So first thing that is done in the wave analyzer is that all the harmonic components, they are removed and only one single frequency, at only that particular frequency will be used, and at that frequency the amplitude and the different other characteristics of the signal, they will be measured. So along with the, if we are saying that we are doing the analysis of a waveform, we are measuring its characteristics like amplitude, frequency, phase angle, etc. Okay, so when we are doing the analysis of the waveform, not only the amplitude, frequency and phase angle of the fundamental, but also the harmonic components will also be displayed on that, or they will also be measured. Okay. Now for the analysis of the waveform, like for the amplitude, frequency and phase angle measurements, the graphical and mathematical methods are used, but the problem with these methods is that these methods are very laborious. Okay, so if we are doing the analysis of a complex waveform, we can instead of using these graphical and mathematical methods, we can use electrical means also, and in that electrical means we are going to pass this waveform through a band pass filter, and this band pass filter is going to remove all these harmonic components. Okay, so only we will be getting the particular frequency, and at that frequency all these measurements can be done. Okay. So that was the basic idea behind the wave analyzer, that we are having a complex waveform, we are having a periodic waveform which is the sum of the fundamental and the harmonic components. Now whenever we are doing any measurements, we are measuring the all these characteristics for both the fundamental and harmonic components. So first our priority is to remove the harmonic components, so only the accurate measurements for the fundamental component is done. Now let's come to the wave analyzer, that what are the circuits which are used in the wave analyzer and what a basic wave analyzer is like. So if we define a wave analyzer, So if we say that wave analyzer, it is an instrument which is designed to measure the amplitudes, the relative amplitudes of the single frequency components in a complex waveform. So in a complex waveform, we are having the different components. So for a particular component, if we want to do, if we want to measure the amplitude at that particular frequency, we are using the wave analyzer. So what the wave analyzer is, it is basically a frequency selective voltmeter. So we can say that wave analyzer is basically a frequency selective voltmeter which is tuned to a particular frequency and which is measuring the amplitude at that single frequency. While all the other signal components, they will be removed. Okay, so only at that one particular frequency we are measuring the amplitude of the signal. Now if we see the block diagram of a basic wave analyzer, it will be like so this is the basic wave analyzer which consists of an LC circuit and a rectifier and the indicating device. Now this LC circuit, it is the primary detector. This LC circuit is going to work at the resonance frequency, and at that resonance frequency it is going to measure the particular harmonic component or particular component of the signal. Okay. So basic wave analyzer consists of an LC detector, a rectifier and an indicating device. What the LC detector or LC circuit does, now the particular frequency at which we want to measure the amplitude, so that frequency will be adjusted in this LC circuit. This LC circuit is adjusted to do the resonance at that for particular frequency which we want to, at which we want to do the measurements. Now next we are having the rectifier. Rectifier is used to obtain the average value of the input signal. After the rectifier, we are having the indicating device, which is simply a DC voltmeter, and this DC voltmeter is calibrated to read the peak value of the sinusoidal input voltage or the value of the amplitude of the input signal. So this indicating device, it is a DC voltmeter giving an indication of amplitude. Now, since this LC circuit, it is tuned to a particular frequency component only, so it is going to pass only a single frequency component through this, and it is going to reject all other harmonic components present in the signal. So only at that particular frequency the amplitude will be measured by the wave analyzer. So in this way, the basic wave analyzer, it works, that how it is measuring the amplitude at a particular frequency. Now, if we talk about the applications of the wave analyzer has its applications in different fields, like for the sound measurements, for the vibration measurements, and for the electrical measurements. It can be used in the laboratories and in different applications in the electrical and electronic field. So in this video, we studied about that what are the various signal analysis instruments present in the laboratories, and out of that we studied about the wave analyzer, what is a wave analyzer, and how a basic wave analyzer works and what are its applications. So I hope that this topic is now clear to you. Thank you.